let's look at how propositions can be broken down. So we'll first start out with a definition for atomic propositions. And at their core, atomic propositions are the basic building blocks of propositions. So, for instance, it is a proposition that cannot be broken down into smaller concepts. If you think of Lego pieces, if you start with just that one piece, that's an atomic proposition. It's something that can't be broken down any further. It cannot be broken down into smaller concepts. Another way of stating that is that it's a proposition that is conceptually indivisible. We cannot break it down into a smaller concept. And an example of these in programming are Boolean variables. A Boolean variable takes on a defined truth value, true or false, but you can't break it down any further. An atomic proposition is something of the form, my car is white. There is nothing about that declarative statement that I can take away and have it still remain a proposition. I live in Halifax. That's either true or false. Pigs can fly. Everything that's listed within that proposition must be there for it to make any sense. But we can also put things together. So we can take other propositions, just as we can take Lego blocks and stick them on top of one another, connect them together. We can do the same with propositions. And those are compound propositions. So it's like a stack of those blocks. And there are rules for how we're allowed to stack them together. Compound propositions are those propositions that are built up of more than one atomic proposition. So they're made up of conceptually smaller propositions. They're built up, they're stacked together. Examples of such include something of the form, my car is white and it is electric. And we could break that down into two smaller atomic propositions. My car is white and my car is electric. And the thing that combines them is that word and, right? I could say I live in Halifax or I live in Ottawa. And we can see that that's broken down into two separate atomic propositions. I live in Halifax takes on the truth value on its own. And I live in Ottawa is either true or false on its own. We combine them together into one larger proposition. I live in Halifax or I live in Ottawa. And then another example is pigs can fly or pigs can swim. Each of those parts takes on its own truth value. And so these are all examples of Boolean expressions, combinations of Boolean values. So the way that we hold those blocks together is through logical connectives. And the logical connectives are just that glue holding the blocks together. So we'll take a look at different ways that we can combine our propositional statements. So let's first look at the negation of a proposition P. The proposition not P, represented as such, is true when the proposition P is false, and false when P is true. It's a negation of that original proposition. And so we'll see below that we have a truth table. And a truth table is just a way that we can represent all possible truth values that each of these propositions can take. And so the first thing that we see is in column 1, it lists all the possible truth values that that original atomic proposition P can take. P can either be true or false. True is represented by the T, false by the F. And then we list out all the values that can be taken as we build up a more complex compound proposition. And so not P, when P is true, not P is false. When P is false, not P is true. Examples of not P. We can start with a basic proposition. P could be, it is raining. That makes not P equal to the phrase, it is not raining. And that's that negation. We can also look at conjunction, and conjunction is our AND operator. It's represented by this wedge, as you can see. So the proposition P and Q, which is how we state that, is true when both of the propositions P and Q are true, and it's false when either one of them is false, or both. So, for example, if we look at that truth table, and here you can see it contains many more rows, and that's because we have to list every possible combination of truth values. So between the two atomic propositions involved in this compound proposition P and Q, we know that we have to look at both the values true and false for each of our propositions P and Q. And so they can take on the combinations true, 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 false, false, true, or false, false as listed. So what this looks like is if both P and Q are true, then P and Q is true. But if ever any one of those is false, the whole proposition P and Q is false. And so for the second, third, and fourth rows of our truth table, at least one of P or Q is false. And so the remaining truth values for P and Q are false. So we see again, the only time that P and Q is true is if both P and Q are true. For instance, let's look at the sentence, I am happy but tired. Sometimes when we see sentences in the English language, they don't always take on the values that you might expect. So, but is not the same as the word and yet what this is really saying is that I'm both happy and tired. And so if we say that P is I am happy and Q is the atomic proposition I am tired, which are both either true or false and can't be broken down any smaller, then what we see here is really I am happy and I am tired, which is the same as P and Q. Another way that we can combine these is using or, the disjunction. And this is represented by a V in between the two propositions that we're going to combine in this way. So P or Q is represented as P v Q. And this is true when either of P or Q is true. So this is different from the and, because if either P or Q is true, then P or Q is true. And it's false only when both the propositions are false. And so if we look at our truth table, we still have all the possible combinations of P and Q, the truth values that those can take, true, 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 false, false, true, and false, false. And to fill in that last column, what we want to look for is all those cases where either P or Q is true. That's where we expect to have true values. And so in this case, we'd see P or Q is true for those first three, and it's only false when both P and Q are false. So in the English language, what this can look like is all sorts of things. The way that P or Q comes up in the English language is when one of two situations might be explored. So, for instance, if you had a document that needed to be signed by a client, you might say that the document was signed by the client or by their parent. And so in the event that the client was a minor, sometimes documents are signed by their parent. And so in this case, we see that it's one or the other. So the document is either signed by the client or by their parent. And we break that down as P or Q, where P is the document was signed by the client, and Q is the document was signed by their parent. and one of those must be true for the document to be valid, then this is an example of P or Q.